Today I am going to discuss the Newton's second law of motion from the chapter Force and Laws of Motion part 2. So first of all, everybody should know how to define Newton's second law of motion. So it is defined as the rate of change of momentum is directly proportional to the force and takes place in the direction of impressed force. This is the definition of Newton's second law of motion. Now come to mathematical formulation of second law of motion. Let us suppose that an object of mass m is moving along a straight line with initial velocity u and it's accelerated to velocity v in time t by applying a force F. Then the initial momentum p1 equal to mu and the final momentum becomes p2 equal to mv. So that the change in momentum P equal to final momentum minus initial momentum, which is P2 minus P1 and which is m into V minus u. Rate of change of momentum m into V minus u by t, and according to Newton's second law of motion we can write F varies as m into V minus u by t or F equal to k m V minus u by t. Here v minus u by t is replaced by acceleration. Okay, so the force becomes F equal to kma, where k is constant of proportionality, its value in SI unit is 1. So the force becomes F equal to ma, and SI unit of force is Newton. So 1 Newton may be written as 1 Newton equal to 1 kg into 1 meter per second square. And now we can define 1 Newton force. So 1 Newton is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kg. Okay. Now dear students, come to learn the Newton's third law of motion. So first of all, we will see what is the statement of Newton's third law of motion. It states that to every action there is an equal and opposite reaction, and they act on two different bodies but they act simultaneously. Now, to prove that action and reaction are equal and opposite, we have considered two spring balances A and B. The spring balance B is fixed to the rigid support, and we pull the spring balance A, which is action, and we see the reaction in spring balance B. Okay, both action and reaction are equal but they are in the opposite direction. So we can say that force exerted by the spring balance A on B is action and the force exerted by the spring balance B on A is the reaction. Now some examples are there to clarify the action and reaction. Here you can see in example 1, when a bullet is fired from a gun, it exerts a forward force, okay, which is action. On the forward force action on the bullet, and the bullet exerts an equal and opposite force on the gun, that is reaction, and the gun recoils. Okay, here you can see that the gun moves in the backward direction. The velocity with which the gun moves in the backward direction is called the recoil velocity of the gun. It is only due to the reaction force on the gun. Now in example 2, when a sailor jumps out of a boat, he exerts a backward force of the boat action, and the boat exerts an equal and opposite force on the sailor, that is reaction, and the sailor jumps forward. You can see in the figure very clearly, it is visible to us. Now some examples of Newton's third law of motion. You can see in example 3, when an air-filled balloon is released, the force of air coming out of the balloon, that is action, exerts an equal and opposite force on the balloon, which is reaction, and it moves upwards. Now in example 4, you see when a rocket is fired, the force of burning gases coming out, which is action, exerts an equal and opposite force on the rocket, which is reaction, and it moves upwards. Now dear student, law of conservation of momentum. So try to learn the statement. The statement is the total momentum of a system remains conserved in the absence of an external force. When two objects strike each other, they undergo action and reaction. these action and reaction change the momentum of each of the striking objects. Although momentum of each object changes, the total momentum of two objects taken together remains the same. Here is in step 1 you can see the two cars 1 and 2 have masses m1 and m2 and velocities u1 and u2 such that u1 greater than u2. They are moving in the same straight line. The velocity of car 1 is greater than velocity of car 2. That is why car 1 strikes the car 2. That is the action force. Okay. So according to definition of momentum, you can write momentum of car 1 equal to m1 u1 and momentum of car 2 equal to m2 u2. These are the momentum of car 1 and 2 and these are initial momentums. Okay. Now total momentum of the system before collision, total momentum of the system before collision is m1 u1 plus m2 u2. Now dear students, after collision the velocities of two cars will be changed. Now in step 2, let car 1 collide with car 2 after collision. Their velocities are v1 and v2 respectively. So total final momentum of the system becomes m1 v1 plus m2 v2 and action force we can write F12 equal to rate of change of momentum of car 1. So it can be written as m1 into v1 minus u1 by t and the reaction force F21 equal to rate of change of momentum of car 2, which is written as m2 into v2 minus u2 by t. As per Newton's third law of motion, action equal to minus reaction, because action and reaction are equal and opposite. So we can write action equal to minus reaction, or we can write F12 equal to minus F21, and then we can put the value, and after putting the value and rearranging them we get the momentum of the system after collision equal to momentum of the system before collision. So this proves that the law of conservation of momentum. This proves law of conservation of momentum. So thank you very much. Now you revise and try to understand. Thank you.